Okay, so we've got to get some of those things taken care of. You got to get out of that circular logic, and you need to be able to talk about the specific scientific principles that support that idea. So I've got up here something that can hopefully help you. Okay, so I'm going to leave this up here, but I'm also going to do it specifically for those three pieces of evidence. So if blank happens, then this is true because of these scientific principles. Okay? So here's where we put our scientific evidence. Here's where we put our claim or our hypothesis. And here is where we have the explanation of our scientific evidence. Okay? So we're going to do this over here. We're going to start with Hubble's law. Okay? Alright, so over here on this board. So I'm going to kind of set this out basically for you, and then we'll go through each of the three pieces, and then you'll have the information you need for your panel, and some help on looking at how you should set that up. Alright, so my if for this one, my scientific evidence for the Big Bang and redshift is all galaxies are doing what?
Being redshifted. Or moving away.
Are redshifted, which is the same thing as moving away. Okay? What is the claim or hypothesis? So if all galaxies or stars are moving away or redshifted, then what? What's my claim or evidence?
That we're still expanding.
So we're expanding as the Big Bang says we would be. Okay? Because now I need to explain the scientific evidence. Okay, I'm going to explain that scientific evidence. So what are some things, what are some of the things that would be an explanation of redshifting? Or some scientific principles, or some scientific evidence that we have to explain? Keegan.
We have to explain how the planet's redshifting relates to the Big Bang Theory.
Okay, so we're going to have to explain what redshifting is, right? So Doppler effect. Good. Yes, tell what Doppler effect is. We're going to talk about, Keegan said, how galaxies would be redshifted. And we're going to want to talk about Hubble's law, which says that the farther away Is that making more sense now?
Yes.
Okay, so what are some things, as it says, they have to be supported with graphs, images, or data? Okay, we could think of some images that we could have to explain the Doppler effect, right? We've done all of those, moving and not moving. Okay? Right? We could talk about how galaxies would be redshifted. We've done spectrometers, right? And when it's redshifted, it's going to be moved. Okay? And we also have done Hubble's law. And you can find those, just like you did on your experiment, distance away and velocity. Okay, if you did the expanding universe with the balloon, you came up with a graph. You can also look at the same graphs that Hubble used. Is that making more sense of what each of those should look like? Okay, let's run quickly through the other ones. We're going to get rid of as much of this as I can. And this is on the video, and I will post it again on the classroom assignment choice grid. But if you want, you can take a picture before I erase it. It's too late. Okay, so our next one is the existence and detection of the cosmic microwave background radiation. Okay, so what evidence or scientific evidence are we using? If we can what?
Detect it with
Okay, so if we can detect it, if we can detect the cosmic microwave background radiation, then what? Okay, if we saying the okay, so if we can detect it, then we're correct in saying that the Big Bang Theory is correct in saying that it was created by it because of what evidence, what supporting evidence would we have to explain?
the stars.
The what?
Stars.
What do you mean by the stars?
I forgot, we were talking about it in that one thing.
How about when and where the cosmic microwave background radiation is supposed to come from? Okay, it's going to be redshifted. Okay, if we've explained redshift in the other one, we can probably just say this would be extremely redshifted. And how we detected it. Okay, so again, let's go through some charts, pictures, and graphs that you could have. When and where. This should be on your timeline, right? Okay, so this is part of your timeline. When it goes from opaque to transparent.
Do we put like the certain year that we talked about the cosmic background and we just put C?
Yeah. Yeah, you could say, you can put a little asterisk or a 1 or 2 and say C, the explanation on panel 1. You can definitely do that. Like, that'd be nice. Okay, so it went from opaque to transparent, or went from a plasma to being transparent. Okay? Does that make sense? Redshift, we've covered what you can explain on redshift. Okay, but you could also just explain why CMB would be away. It should be the fastest moving thing and it should be the farthest away, right? Because it's the oldest thing we should be able to see. How we've detected it. What are some ways we've detected it?
In the TVs.
Okay, we can see it on our TV. The two guys on Cosmic Times that built the radio telescope. Okay, so you can talk about them. And we also have specific satellites that we use today. Okay, we can also get pictures. Pictures of the cosmic microwave background radiation, okay? Does that help? Okay, let's walk through, want to do the last one? Or does it make sense?
It makes sense.
So skip the last one or do the last one?
Whatever you want to do.
I want to know what you want to do. Okay, there are some people saying they can want to do the last one. If you want to skip the last one, you can begin working on other stuff, but you have to make quiet because we still want them to hear it. Okay, our last one is the 3/4 hydrogen, 1/4 helium. Okay, that was made. So if we detect, or if the universe is 3/4 hydrogen and 1/4 helium, then we're correct in saying okay, evidence would we have to explain, what scientific evidence would have to be explained under this one? Say that? What? Nothing? Okay. Anybody else?
There's still 3/4 hydrogen and 1/4 helium.
Good, we can still detect those amounts. We should also explain how explain how it created those elements and which ones, right? Because it made primarily just hydrogen and helium. It didn't make very many things heavier than that, right? It's where in stars where those heavier things are made. Okay, so how it created those? So it's hot, it made nuclei, okay, all of those timeline type of things that we have. Okay, and how do we detect it today? Okay, and when we look, we still see 75% and 25% today. Okay, again, we gotta show and explain the evidence that supports what we said.
How do we know that there was 3/4 and one? How do we know there's 3/4 helium and 1/4 hydrogen? Well,
Other way around.
Other way around. But how did we know that if we couldn't study? Like, how did we know it was there?
Okay, good. So this is what's called Big Bang nucleosynthesis. Does anybody know what synthesis means? You synthesize something to make something, okay? And nucleo is what? Okay, good. So the theory of the Big Bang nucleosynthesis is how the Big Bang made nuclei, okay? And when we do that theory, what we do is we're essentially running everything back in time, saying, okay, if the universe is getting smaller and smaller and smaller, when it gets to this point, it's going to be this temperature. It's going to have this much stuff in it. The stuff's going to be this close together, okay? And when we do that, Keegan, we can look at that and we can say, okay, now if we run that forward, that way it should have gone. At this temperature, it would have had enough time to make this much hydrogen, and would have had enough time to make this much helium. Okay, and that's where we get those calculations of 3/4 hydrogen, 1/4 helium. Okay, and then we test that today by looking at it, and we say that's still basically true today. Okay, does that help?
Yeah.
Okay. Any other questions? Questions, please.
Would that be a good thing to put on our
Definitely a great thing to put on the poster. Yes.
I just use the nuclear,
In this?
No, we still like nucleus.
Because they all talk about the center. That's what they're all about. Okay? All right. The rest of the time is yours.